Welcome to this deep dive, you know, into generative AI.
Oh, yeah.
It's a field that's just like exploding right now.
It really is.
And for good reason. I mean, just imagine a tool that can paint like Van Gogh or, compose music like Mozart,
Right.
but it's not human. It's AI.
Yeah,
That's what we're talking about here.
it is.
AI that doesn't just analyze data, it creates brand new data, things that never even existed before.
That's right.
And by the end of this deep dive, you're going to have like a really solid grasp of the main types of generative AI,
For sure.
how they work, and even get like a peek at some simple code examples.
It's a super exciting time to be following this technology. The creative potential is immense.
Yeah, so to really appreciate like what's happening right now, let's take a quick trip, down AI memory lane.
Absolutely. We need to understand the bigger picture,
Right.
right? So, in the early days, we had rule-based AI,
Mm.
which was basically just computers following strict instructions.
Right.
And then came machine learning,
Yeah.
where algorithms could actually learn from data
Yeah.
and improve their performance. So think about like teaching a computer to play chess. By feeding it tons of game data, that was a big leap forward.
Right, and then things got really interesting with deep learning.
Exactly. Deep learning utilizes these neural networks,
Yeah.
which are inspired by the human brain.
Okay.
These networks can process massive amounts of data and uncover complex patterns,
Wow.
leading to breakthroughs like AlphaGo,
Right.
the AI that beat the world champion Go player.
Yeah.
Back in 2016, that victory really showcased the power of deep learning
Huge.
and set the stage for the generative AI boom we're seeing now.
Yeah, so deep learning laid the foundation, and now generative AI is like building on that foundation to create some pretty amazing things.
Yeah.
What are some of the like most exciting applications that you're seeing out there?
One that immediately comes to mind is, in the realm of art and design, we now have AI generating artwork, creating design prototypes, and even building entire virtual worlds.
So we could soon have like AI collaborating with human artists and designers,
Yeah.
pushing the boundaries of creativity even further.
Absolutely. It's not about replacing human creativity,
Right.
but rather augmenting it and exploring these new avenues for expression.
I like that.
And then there's content creation. AI is writing stories, composing music, even helping to make films. It's still early days, but the potential is huge.
I imagine AI like helping you write a screenplay or coming up with a catchy jingle for a commercial. The possibilities just seem endless.
They really are, and it's not just the creative fields. Generative AI is making waves in healthcare, too.
Oh, wow.
For example, it's being used to create synthetic medical data, like realistic MRI scans. This is especially valuable for rare diseases, where real data is scarce, and this synthetic data can be used to train algorithms and potentially help with diagnoses.
That's like having AI create like a virtual patient
Yeah.
for doctors to learn from and practice on incredible.
And we're just scratching the surface of its potential in healthcare.
Yeah.
From drug discovery to personalized medicine.
Wow.
Generative AI is poised to really revolutionize the field.
And it's shaking up the gaming world too, right?
Absolutely. It's being used to create dynamic game worlds,
Yeah.
unique characters,
Mhm.
even procedurally generated storylines. This means every gaming experience could be completely unique and unpredictable.
Wow, that takes immersive gaming to a whole new level.
It does.
Okay, I'm definitely sold on the wow factor,
Okay.
but I have to admit some of the technical terms can be a bit confusing.
Sure.
Can we break down some key terms just to make sure we're all on the same page?
Of course. Let's start with the basics. Artificial intelligence, or AI, is kind of like the umbrella term for any attempt to create machines that exhibit intelligent behavior.
Okay.
Then we have machine learning, which is a subset of AI.
Mhm.
It's all about algorithms, learning from data, and getting better at a task without being explicitly programmed. So how we learn from experience.
Right. And then deep learning is like a further subset of machine learning.
Yes.
And that's where those brain-inspired neural networks come in.
Exactly. Deep learning uses these neural networks to model complex patterns in data. It's like nesting dolls.
Yeah.
Deep learning within machine learning within AI.
Okay.
Now let's talk about models, algorithms, and data sets. The building blocks of generative AI.
Okay, so what exactly is a model in this context?
Think of a model as a mathematical representation of a system or a process. It's kind of like the blueprint that guides the AI in learning and generating new data.
Okay.
Algorithms are the step-by-step instructions or the recipe that the model follows.
Uh-huh.
And finally, data sets are the fuel for the AI. These are massive collections of data used to train the models.
So the quality and variety of the data is like crucial.
Absolutely. It's garbage in, garbage out.
Right.
If you train an AI on a flawed data set, you'll get flawed results.
Makes sense. Okay, now let's get to the heart of it all, neural networks.
All
They
right.
sound pretty complex.
They can seem that way,
Mm.
but the basic idea is actually fairly intuitive. Imagine a network of interconnected nodes, kind of like a spider web,
Okay.
where each node represents a simple processing unit.
And these nodes are arranged in layers, right?
Exactly. There's an input layer where data enters the network,
Mm-hmm.
multiple hidden layers where the real processing happens, and an output layer where the result is produced. Data flows through this network, getting transformed at each layer. The more layers you have, the deeper the network becomes, allowing it to learn more complex patterns and relationships.
Okay, now I'm starting to see the resemblance to the human brain. It's processing information in layers.
Yeah, it's a great analogy. Each connection between nodes has a weight
Okay.
representing its strength. As the network learns it, it adjusts these weights, getting better at producing the correct output.
So it's constantly like fine-tuning its understanding of the data.
Exactly.
Can you give like a concrete example of this?
Yeah, let's go back to that cat picture example.
Okay.
Imagine feeding a neural network thousands of images of cats. The network analyzes these images pixel by pixel, identifying patterns, the shapes of ears, the texture of fur, the position of eyes.
And those patterns get stored in the hidden layers.
Precisely, each hidden layer extracts higher-level features, building upon the patterns learned in the previous layer. It's like going from simple shapes to more complex features until the network truly understands what a cat looks like.
Right.
Once it has learned these features, it can use them to generate new, unique cat images.
That's incredible, but how does this look in actual code? I'm kind of curious to see how these networks are built.
Let's take a look at a simplified code example of a GAN, or Generative Adversarial Network, one of the most popular generative models.
Bring on the code.
Don't worry, we keep it simple. This snippet shows the structure of a GAN.
Okay. Yeah.
All right, so
There's a lot going on there. Can you walk us through it?
of course, this code defines two key components, the generator and the discriminator. The generator takes a random noise vector as input and transforms it into something meaningful, like an image that resembles a handwritten digit.
So it starts with something completely random and shapes it into something we recognize.
Exactly. Then we have the discriminator. It acts like a judge,
Okay.
analyzing an image to determine if it's a real image from the training data
Uh-huh.
or a fake image created by the generator.
So it's like a game where the generator tries to fool the discriminator and the discriminator's trying to catch it.
Precisely. That's the adversarial process that drives the learning in a GAN. The generator gets better at creating realistic images,
Okay.
while the discriminator gets better at spotting fakes as they compete. They both improve,
That's such a clever way to train a model.
right?
So we've got neural networks as the foundation, and GANs are one type of generative model that uses them. What other types of generative models are out there?
There are a few, but let's focus on two more VAEs, or Variational Autoencoders and Autoregressive Models.
Okay. What's special about VAEs?
So VAEs, they work by encoding data like an image
Okay.
into a compressed representation called a latent space.
Oh.
And then they decode this representation back into the original data space.
So it's like squeezing the data into a smaller package.
Yeah,
And then unpacking it again.
exactly. But VAEs go a step further. They learn a probability distribution
Okay.
over the encoded data, which means they're not just memorizing the input, they're learning the underlying structure and variations within the data.
Can you give me an example?
Yeah, imagine training a VAE on images of handwritten digits.
Okay.
The VAE learns to encode each digit into a set of numbers representing its key features, like the slant, the curvature, the thickness of the lines.
So each digit gets like its own unique code.
Right. But more importantly, the VAE can then generate new unique digits by sampling from this distribution of codes.
Okay.
It's not just copying existing digits. It's
Yeah.
creating entirely new ones that still fit the pattern.
That's fascinating. What kinds of applications are VAEs good for?
They're great for anomaly detection, which is like spotting outliers in data. They're also useful for data compression
Okay.
and, of course, generating new images.
Yeah, I'm seeing how these different models each have their own strengths.
Yeah.
Can we see a code example of a VAE to get a clearer picture of how they're built?
Absolutely. This snippet shows the basic structure.
Okay.
All right, so,
That's definitely more complex than the GAN code. Can you break it down for us?
of course, this code defines three main classes: the encoder,
Okay.
the decoder, and the VAE itself. The encoder takes the input data like an image and compresses it into that lower dimensional latent space we discussed.
So it's finding the most essential information in the image.
Exactly. Then the decoder takes this compressed representation and tries to reconstruct the original image.
Okay.
This encoding and decoding process forces the VAE to learn the most important features of the data.
Got it. And the VAE class combines the encoder and decoder
Yes.
while also introducing that probability distribution in the latent space,
Right.
which is what allows it to generate new, unique data.
Precisely.
Okay, so we've covered GANs and VAEs. What about those autoregressive models you mentioned earlier?
Yeah, so autoregressive models are all about prediction. They predict the next element in a sequence based on the previous elements.
Okay.
Think of predicting the next word in a sentence or the next note in a melody.
It's like the autocomplete feature on our phones,
Yeah,
but way more advanced.
exactly. A great example is the recurrent neural network, or RNN.
Right.
RNNs excel at handling sequential data, which makes them perfect for things like language modeling and time series prediction.
So how are RNNs being used in content creation?
Let's say you're building a chatbot.
Okay.
You can train an RNN on a huge data set of text conversations. The RNN learns the patterns of human language, how words and phrases are typically strung together, essentially learning the grammar and the syntax.
So it can have a realistic conversation.
Exactly. Once it's learned these patterns, it can generate new text that resembles human conversation.
Wow.
That's how these powerful language models like GPT-3
Right.
are able to produce such realistic and engaging text.
That's pretty impressive. Can we see some code for a basic RNN?
Of course, here's a snippet demonstrating its structure. All right.
Can you walk us through this code?
Absolutely. It defines a sequential model, meaning the layers are processed one after the other.
Okay.
The first layer embedding converts words into numerical vectors that the RNN can understand. It's like translating human language into machine language.
Makes sense. What do the simple RNN layers do?
They are the core of the model. They
Yeah.
process the input sequence word by word and keep track of the context from previous words. It's like the RNN has a memory allowing it to generate more coherent and meaningful text.
That's amazing. And the dense layer at the end.
That layer outputs a probability distribution over the vocabulary, essentially predicting what the next word in the sequence should be.
Okay, I'm starting to see how these different models each have their own unique strengths. GANs for realistic images.
Right.
VAEs for learning data distributions, and RNNs for processing sequential data. It's fascinating how they all work together.
It really is, and we've just scratched the surface. But before we get too carried away, there's one more type of neural network we need to discuss: transformers.
Transformers like those robots in disguise.
Not quite, but they are transformative in their own way.
Okay.
They've taken the world of natural language processing by storm.
Okay. I'm intrigued what makes Transformers so special.
So unlike RNNs, which process data sequentially, transformers can process entire sequences of data at once.
So instead of going word by word, they can see the whole sentence or even a paragraph.
Exactly. They achieve this through a mechanism called self-attention.
Oh,
It allows the model to understand how different words in a sentence relate to each other.
so it can understand the context and nuances of language much better.
Precisely, that's what makes transformers so powerful for these language tasks,
Right?
from translation to text summarization, and of course, generative AI.
I'm starting to see the connection. So how are they being used in generative AI?
Two popular examples are GPT and BERT. You've probably heard of them.
GPT rings a bell. Isn't that the model behind this impressive text-generating AI?
You got it. GPT, which stands for Generative Pre-trained Transformer, is specifically designed for text generation.
Okay.
It can write stories, poems, articles, even code, all with remarkable fluency and coherence.
What about BERT?
BERT, or Bidirectional Encoder Representations from Transformers, focuses on understanding language.
Okay.
It's great at question answering sentiment analysis
Uh-huh.
and understanding the relationships between words.
So GPT is the creative writer, and BERT is like the analytical reader.
That's a great way to put it. And both of these models are pre-trained on massive data sets of text. They already have this vast knowledge of language built in, which makes them really easy to use.
Wow, that's like having a team of language experts at your disposal.
Yeah.
Can we see how these transformer models are implemented in code?
Absolutely. Libraries like Hugging Face Transformers have made it incredibly easy to use pre-trained models like GPT and BERT.
Okay.
Here's a snippet showing how to generate text using GPT.
Awesome. That's remarkably simple. So with just a few lines of code, we can tap into the power of these advanced language models.
Exactly. AI development has become much more accessible, these pre-trained models.
Yeah.
Let developers and researchers build sophisticated applications without having to train models from scratch, which can be very time-consuming and resource-intensive.
Right. Okay. My head is spinning with all these incredible models and techniques.
Sure.
I have to admit, though, I'm feeling a bit overwhelmed.
Of course.
How can someone like me, a non-expert,
Right.
get started with generative AI?
That's a great question. It's understandable to feel a bit intimidated,
Yeah.
but building your first generative AI model is more attainable than you might think.
Okay, that's reassuring. Where do we even begin?
The first step is setting up your development environment. Python is the go-to language for AI development these days.
So Python is our trusty sidekick on this journey.
Exactly. And once you have Python installed, you'll need some essential libraries.
Mm.
These libraries provide the tools and functions to build, train, and evaluate your generative models. Two of the most popular ones are TensorFlow and PyTorch.
It's like choosing the right tools for our AI workshop.
I like that analogy. Both TensorFlow and PyTorch are great options.
Okay.
They both have pros and cons, so it often comes down to personal preference and the specific project you're working on.
What about other libraries? Any that we should know about?
If you're working with transformers, the Hugging Face Transformers library we mentioned earlier is must-have.
Okay.
Gives you easy access to those pre-trained models like GPT and BERT, saving you a ton of time and effort.
Right.
And if you're working with images, libraries like OpenCV and Pillow are great for image processing.
Okay, so Python libraries, what's next?
Now, for the fun part, creating your first generative model, let's walk through the steps of building a basic GAN using TensorFlow.
Bring on the code.
First, we need to define the structure of our generator and discriminator.
Mm-hmm.
Remember, we have that two-player game where the generator is creating fake data and the discriminator is trying to spot it.
Right, that back and forth competition that makes them both bad.
Let's say, here's the code for a simple generator.
Okay,
So
that looks a bit like the Jan code from earlier.
this defines a sequential model, meaning the layers are processed in order. We're using dense layers, which means each node in the layer is connected to every node in the previous layer.
And what are ReLU and TON?
Those are activation functions. They introduce nonlinearity into the model, which lets it learn more complex patterns.
So they add a little complexity to the recipe.
Exactly. Finally, we reshape the output to match the dimensions of our target image. In this case, we're generating 28 by 28 pixel grayscale images like those handwritten digits.
Okay, so that's the generator. What about the discriminator?
Here's the code.
All right.
Right.
It looks similar to the generator, but with a few key differences.
You're right. The discriminator also uses dense layers and activation functions. But notice the last layer, it only has one output node with a sigmoid activation function.
So it's giving a simple yes or no answer. Is this image real or fake?
Exactly. The sigmoid function outputs a value between 0 and 1, representing the probability that the input image is real.
Got it. So we've defined both the generator and discriminator. What's next?
Now we need to compile our models. This means choosing an optimizer, a loss function, and any metrics we want to track.
Those sound important. What do they do?
The optimizer controls how the model updates its weights during training. It's like choosing the best path to reach our destination, the best possible set of weights.
And the loss function.
The loss function measures how well the model is performing. It quantifies the difference between the model's predictions and the actual values.
So it's like a scorecard that tells us how well we're doing.
Exactly. And finally, metrics are additional ways to measure performance and give us insights into how the model is learning.
Okay, so compile the models and then what?
Then comes the exciting part, training.
Okay.
We feed data to our models, let them learn and observe as their performance improves.
I'm ready to train. What kind of data do we need for this, Jan?
For this example, we'll use the MNES dataset,
Okay.
a classic collection of handwritten digits.
Uh-huh.
It's a great starting point because it's relatively small and easy to work with.
So we're going to teach our Jan to create its own handwritten digits.
Exactly. The generator will get random noise as input
Okay.
and try to transform it into images that look like handwritten digits. The discriminator then judges whether these images are real or fake, providing feedback to the generator.
And this feedback loop drives the learning.
Precisely. The generator and discriminator are locked in this adversarial game, constantly pushing each other to improve way. The generator gets better at creating realistic digits, and the discriminator becomes better at spotting fakes.
It's like a digital arms race.
It is.
How do we implement this training process in code?
We set up a training loop where we iterate over our data set, feeding batches of data to our models and updating their weights based on their performance.
Can we see an example of that code?
Absolutely. Here's a simplified training loop for our GAN.
Okay.
All right.
Wow, that's a lot of code. Can you break it down?
Of course, first we load and prepare the MNIAS dataset.
Like prepping the ingredients before we start cooking?
Exactly.
Yeah.
Then we set the training parameters like the number of epochs, which is how many times we'll go through the entire dataset, and the batch size, which is how many samples we process at once.
Like deciding how many times to stir the pot
Right.
and how much we add in at each stir.
Great analogy. The rest of the code is the training loop.
Okay.
We feed the models batches of real and generated images. The discriminator learns to distinguish between them, and the generator learns from the discriminator's feedback.
They're constantly learning and improving in this back and forth process.
Exactly. And as training progresses, we can track the model's performance by looking at their loss and accuracy.
So once the training is done, how do we know if our GAN is actually working?
That's where evaluation comes in. We need to assess how well our generator can produce those realistic handwritten digits. We can visually inspect the generated images to see if they look convincing.
So we get to see what our GAN has created.
Absolutely. This code generates images from our train generator.
Cool.
All right, so
Amazing. So we've walked through building and training a generative model. What are some of the challenges we need to be aware of when working with this technology?
one of the biggest is data generative models need massive amounts of high-quality data to learn effectively.
So it's not just about the quantity of the data, but also the quality.
Absolutely. The quality, the diversity, and the relevance of your data will directly impact the performance of your model.
Where do we even find these massive data sets?
Many publicly available data sets are great starting points.
Okay.
MNES Cipher 10 ImageNet are good examples.
Yeah.
But if you need data for a very specific task, you may need to collect your own.
Data collection sounds like a huge undertaking.
It can be, you have to consider factors like data privacy, security, and quality. You also need to make sure your data is properly labeled and annotated, especially for supervised learning tasks.
Okay, so data is crucial. Any other challenges?
Another challenge is computational resources. Training these models, especially large ones, can require significant computing power.
So we might need access to powerful GPUs or cloud computing services.
It can definitely help. Luckily, cloud platforms like Google Colab and Amazon SageMaker have made it easier for individuals to access those resources.
That's good to know. What about evaluating these models? Is that a challenge too?
It can be. Evaluating generative models is a bit tricky. It's not always clear-cut how to measure the quality and realism of the generated data.
So it's not as straightforward as just calculating accuracy.
Right. There are metrics like inception score and fresh-head inception distance for quantifying the quality and diversity of images. But even these have limitations. Often, human evaluation is still the gold standard.
Okay, so there are some definite challenges, but with all these challenges, why are we even bothering with generative AI? What makes it worth the effort?
The potential benefits are enormous. Generative AI could revolutionize so many industries, from art and design to healthcare. Imagine AI generating personalized educational content, creating truly lifelike virtual assistants, or even designing new drugs to cure diseases.
Those are some ambitious goals.
They are. But generative AI is already making progress in these areas. We're seeing AI generating realistic medical images to help with diagnoses, composing music for films and video games, and even writing articles and scripts that are indistinguishable from human-written content.
It's not about replacing human creativity, it's about amplifying it.
Exactly. Generative AI is a powerful tool that can unlock our creativity and help us solve problems in new and innovative ways. It's a technology with the potential to reshape our world for the better.
I'm definitely excited about the future of generative AI, but as we wrap up, I'd love to hear your thoughts on what we can expect to see in the coming years. What trends and developments should we be watching for?
Well, the field is evolving so quickly, it's hard to predict exactly what the future holds.
Yeah.
However, one trend that's clear is the increasing accessibility of AI.
Okay.
Tools and platforms making it easier for anyone to experiment with and build these models, even without a deep technical background.
So AI is becoming more democratic.
Absolutely. We're also seeing a push towards more powerful and sophisticated generative models. Researchers are constantly innovating, pushing the boundaries of what's possible.
So even more realistic and impressive content in the future.
Another exciting area is the integration of generative AI with other technologies like virtual and augmented reality.
Okay.
Imagine interacting with AI-generated characters in immersive virtual worlds,
Wow.
or having AI create personalized augmented reality experiences.
That sounds straight out of science fiction.
It does, but these are the possibilities generative AI is opening up. It's a technology that has the potential to transform our lives in countless ways, both big and small.
This has been an incredible journey exploring this fascinating field with you. But before we wrap up, I'd love to leave our listeners with something to ponder
Okay.
as they continue their exploration.
I'd like to leave them with this thought. Imagine a future where generative AI isn't just a tool for creating content, but a partner in creativity innovation and problem solving, a future where AI helps us push the boundaries of human imagination, discover new knowledge, and create solutions to some of the world's most pressing challenges.
That's a powerful and inspiring vision. It's a future that we can all contribute to, even if we're not AI experts. But
Yeah.
whether we're learning more about this field, experimenting with AI tools, or just staying informed about the latest developments, we can all play a part in shaping the future of generative AI.
Absolutely. The future isn't set in stone. It's a future that we're creating together. And it's a future filled with amazing possibilities.
It really is incredible to think about like all the potential. And like you said, it's a future that we're creating together. We're not just passive observers.
Right.
Speaking of creating, one area where generative AI seems poised to have a huge impact is, in personalized experience.
Oh, absolutely. Imagine a world where AI can tailor content products and services, to your unique needs and preferences.
Right.
Think about like an AI assistant that knows your taste in music or art and can recommend new things you'd love.
That would be amazing. No more endlessly scrolling through streaming services trying to find something to watch.
Exactly. Generative AI could analyze your past behavior,
Mm.
your preferences, even your mood,
Wow.
to create truly personalized experiences.
Right.
It could curate news feeds, design custom clothing, even create personalized fitness routines.
It's like having a personal concierge, stylist, and trainer all in one.
That's a great way to put it. And this personalization goes beyond, just individual experiences.
Mm.
Generative AI can also be used to create personalized educational content.
Oh, wow.
Lessons and activities could be tailored to each student's unique learning style and pace.
That could revolutionize education. Learning would become much more engaging and effective.
I agree. And in healthcare, generative AI could help develop personalized treatment plans, taking into account a patient's genes, lifestyle, and medical history.
So it's moving away from that like one-size-fits-all approach to something much more precise and effective.
Exactly. Generative AI has the potential to make healthcare more preventative and proactive, giving people more control over their health and well-being.
I'm loving all these possibilities, but let's bring it back down to earth for a moment. What can our listeners do today to start exploring the world of generative AI? What are some practical first steps?
Well, there are tons of resources out there for anyone who wants to learn more or even start building their own models. One great starting point is online courses and tutorials. Platforms like Coursera, ADX, Udacity
Right.
offer courses on AI and deep learning, many of which cover generative models specifically.
So we can get a solid foundation in AI from the comfort of our own homes.
Exactly. And once you have a grasp of the basics, you can start experimenting with AI platforms and tools. Google Colab is a fantastic free option.
Yeah.
It gives you access to powerful computing resources and pre-installed libraries, making it easy to dive right into building and training models.
So it's like having a virtual AI lab at your fingertips.
Precisely for those who like to get their hands dirty with code. There are also lots of open-source generative AI projects on platforms like GitHub. You can explore existing code, experiment with different models, and even contribute to these projects.
It's amazing to think that anyone can contribute to this field even without a formal background in AI.
Absolutely. The open source community is a big part of what's driving innovation in AI. And finally, I encourage everyone to stay curious and stay informed. This field is constantly evolving. Follow AI researchers and organizations on social media, attend conferences, and engage in conversations about AI. The more we learn and understand, the better equipped we'll be to navigate, these exciting changes ahead.
That's great advice. This has been an incredible deep dive into the world of generative AI. It's clear that this technology has the power to reshape our world in some pretty profound ways, from how we create art to how we approach healthcare.
I completely agree. And as we continue exploring and harnessing this power, it's important to do it thoughtfully and responsibly. Generative AI has incredible potential for good, and it's up to us to guide its development in a positive direction.
Well said. It's been fantastic exploring this field with you, to our listeners. I hope you're feeling inspired and empowered to continue your own explorations. Keep learning, keep experimenting, and keep imagining the possibilities.
And as you do consider this, what happens when AI models evolve beyond, simply mimicking human styles and begin to express something like their own artistic intentions? How will that change our understanding of creativity itself? Food for thought as we venture further into this exciting new frontier. Until next time.